Okay, I'm gonna get the stream set up for a second. It's gonna be a moment. Okay, it's going to be a second before I start the stream. Okay, I'm going to be starting it in a second. Okay, cool. Welcome to another episode of the Real Hacker Hours podcast. Today we're going to be doing something a little bit different, where this episode we are going to be streaming it. So, okay, cool. Let's get started. Today we're going to continue working on the static bug finding tool I've been working on utilizing Ghidra's API. Excuse me, I have the hiccups right now. Okay, cool. Right now I am writing a check for printf for a format string. Let me specify exactly what I mean by that, and I'll show you the test case. Something like this format string, and let me show you the source code, basically where printf is only taking a single argument that is user controlled input, and then we can just specify a format string argument for it. Here is the check here. Effectively how I plan on going about doing it is via, and at least this is my initial approach, was first checking to make sure that the P-code arguments, that there are only two, because if you look at the P-code argument right here, the first one, it is calling printf, which we can verify that. So if it is a format string argument like this, it should only have one argument. So that's the first check that we can do. The second check we need to subsequently do is this argument to a static string, or is it actually a variable? For that, what I initially tried to do was just check if this var node is constant, but that didn't work, because what we need to do is we need to look at the definition of the var node. So right now, I'm going to run, this is the test case for printf001, which that is when printf is having static string. Let me show that here. Okay, cool. Yeah, we can see here printf is just printing a single string, and we see here this is the declaration of, or the definition of, the input var node. So we're going to need to effectively find a way to look at the definition and analyze if that is indeed a string. Now what I think is the good way to do this is, first off, I'm going to write a bit of code here. Okay, I'm going to iterate through for var node. What def var node? I'm going to iterate through the var nodes of the definition, particularly the inputs to it. And for clarity's sake, let me just show a few things. Okay, cool. So just to reiterate, this right here is the actual, I'm going to edit the print statements to make this a bit more legible. System.out.println, just going to print some new line characters followed by. Okay, going to run this again. Okay, so here we're printing, this is the P code that we're looking at for the format string. This is the definition of the input for our node, so this is right here. For this, it's taking inputs, these are the inputs and this is the output. What I would like to do, the reason why it has an output is because this is where the var node is getting defined, with the output being the var node that we are looking at. So what I'm going to do is I'm going to iterate through the inputs, check which one is constant, and if it is constant, I'm going to assume that is an integer, sorry, not an integer, an address to a string, and try to get a string that is at that address. And if that's possible, and if I can actually get a string, then I know it's not variable, and if I can't get a string, I just assume that it's variable, and let's see how it goes from there. So for that, this is where this for loop is going to come in handy. I'm going to iterate through all of the for nodes of the input for the definition P code. We can then write a check just to make sure that if it is constant, okay, so we're going to need to get the string. Now, one thing I did do when I was writing the sprintf check is get string at data address. Okay, cool. I already wrote two functions that, well, this first function, get address from offset, we pass it in offset, which is just the actual integer value of the address. So let's say if we're looking at address 0x40, we'd pass it the actual integer 0x40. And then we have this function right here, get string add, which you pass it a Ghidra address. Excuse me, my horse is a little bit, sorry, my throat is a little bit hoarse right now. We pass it a Ghidra address, and it will return a string at its location if there is a string. And I'm going to take a look to see what does it return if there is no string there. If there is no string there, it just returns effectively an empty string. So what we can do is I'm just going to copy these over to another tab. Let's go to check format string. And let's go ahead and effectively long offset equals def var node.get offset. Get the address from it. Get the string from it. If format string dot equals, I think this is how we do string comparisons in Java. It's been a while since I've done this. So if it does not equal to effectively an empty string, that means it is a static string it was able to resolve, so it is not a format string bug, so you can just return. And then from there, oh hi Nazim Ari, what's up? Just saw you in the chat. Okay, cool. If you have any questions, just say them in the chat. I'm going to try my best to answer them. So, getting back to here, if you've reached this point, then we've iterated through all of the inputs for the definition P code, and we're not able to get a string from any of the inputs, so chances are it's not a static string, meaning that we have a format string or potential format string bug, so you can go ahead and report it. Now, let's see if this will go ahead and work. Right now we're running this on the printf001 test case, which when we look at it, you see the printf call is being made to a static string, so it should not flag it. Let's go ahead and see if it works. Okay, this did not flag it. That is good. Let's try running it against printf000, which in this case it is running it against a variable that stores our input, so it should flag it. Okay, this one did indeed flag it. So that's a good first step for the format string with printf. So I'm just going to go ahead and mark that as done for now. Of course, once we get past the POC stage, I say POC stage meaning that we rate the checks and successfully run them against just some basic simple binaries like we see over here. We will need to go through and run this tool against a ton of different actually large targets. That way, all of the problems we're going to see with a tool like this, we're not going to be able to just find them via throwing them against simple binaries. So next up on a list of functions remaining are going to be scanf and fscanf. Scanf effectively, as you probably know, scans in data into a buffer, into a region of memory, and you specify via a format string. And fscanf effectively does the same thing, but with you specify with a file string pointer, where a scanf, I believe it just works through standard in. So let's go ahead and write some checks for it. So for at least for the first check, what I'm going to want to check for just saw someone in the chat say doesn't like Ghidra's API because of Java. Yeah, I kind of feel that. Okay, cool. So now, although one thing you have to give Ghidra is it has a ton of different architectures it supports, which is pretty nice. So let's go ahead and write the check for scanf. Now, what is this going to mean? We're going to need to add in, I'm going to go ahead and add the enum for it. Scanf equals 10. We're going to add it to the list of functions that actually do need to be checked. Also, for anyone that's like probably a lot of the people watching the stream right now, what I'm currently doing with Real Hacker Hours, the podcast, is a lot of the previous videos have been about me making this tool. So if you're just watching this starting out, there's probably going to be a lot of like things that you might have like missed or not. Feel free to go back and watch it, or just yell at me in the chat to explain something. Okay, cool. So we have this. I'm also going to add a check type. Okay, let's add it to our switch statement down here. Also, yeah, quick recap for those that aren't familiar. How this tool effectively works is you specify set amount of functions, like here read gets, f gets, memcopy, sprintf, store copy, and you specify a check type, and it will just iterate through all of the calls to this function and apply the check type to it. The check types are defined here, and analyze scanf function to analyze in the reference, and then we break. And the check types are defined here in a list. Now, what I do with the check types is, actually, let me finish writing this function first. Is in here, I'll actually specify the types of checks I want done. Now, the reason for that being is for a lot of these, for a lot of these functions or check types like read, f gets, f read, the type of checks that I'm doing are effectively the same. And doing it in this way allows me to quickly, effectively repurpose existing checks to use against different functions. So I can easily just add a ton of different functions to it for it to check. No, excuse me, my throat's a bit hoarse right now. For analyze scanf, I'm going to want a check scanf %s. Excuse me. For this, let's go ahead and make the function for it, even though I probably should have done that prior to writing that function. I'm going to start off by just, actually, it's going to be closest to the sprintf check, so I'm going to copy that check. Now, one thing I will do is after I'm done writing like the last few checks for these is I will look at all the checks, look at the repeater functionalities, and offload them to helper functions, because you can probably see some code reuse and that's pretty bad. So, okay, what is the check name for this? Check scanf %s. Go change it to scanf %s. Cool. And for this, we're gonna want the arguments. There's a function argument, and this is the actual function that we're looking at. So, like, let's say if we're looking at the fgets function, this will be the actual Ghidra function. And also, what a function is in the Ghidra API, there is a what do you call it? A custom object or class that is actually how Ghidra models functions. That's what this is. You have the reference for the individual call. And this last one is an argument specifying the index of the format string argument. That way we can use it against multiple functions where effectively we're checking for the same thing like scanf, fscanf. However, the index of the argument we're looking at is different. So we go ahead. This effectively just decompiles the function and gets us the p codes for the particular address that we're looking at. This one iterates through the p codes associated with the address, since there could be multiple p codes associated with an individual address, and gets us to the actual call p code that we're looking for. Gets us the var node for the individual input that we're looking at. And this one, actually, now that I think about it, this is exactly the same check. Yeah, I don't actually need to change anything, because here it gets the input var node, here it gets the offset from the definition that is being established. This here gets the address of the offset, here it gets the string associated with it, and here it's just checking if it's %s, so likely I'll just be able to use the sprintf, the %s check function to analyze reference, and the position of the argument is 0. I index it with the first argument being 0. So we don't actually need another function. I just realized. Okay, cool. Just gonna go ahead and run it again, just to make sure that we didn't like forget a semicolon or anything. I probably did. Oh yeah, that's one mistake there. Did percent with an M instead of an N. Okay, cool. I'm going to go ahead and write a test case for fread now. No, not fread, scanf, my bad. I got it mixed up for a second. Copy this test case here. Oh, wait. Okay, let's move this source code of file over to scanf000.c. Edit the make file. Go ahead and make it. Okay, we can compile it. That's good. Let's go ahead and add in the scanf call. It's going to be scanning in via %s, so it's a type of bug we're looking for into target. And let's go make sure that it's actually a bug, that we didn't do a mistake somewhere. Okay, it is a stack bug. That is good. That is what we're looking for. Okay, let's try using this check against it. Okay, we will have to import the binary. Since we're using Ghidra's headless analyzer, we have to first import the binary to run it, and then after it we can process it. So this is scanf. Okay, and let's see what happens. Okay, it took it just fine. However, it did not flag it, so something is wrong here. We had to change it from tag import to tag process since the binary is now imported into the project. Let's go ahead. I'm just going to throw in a print statement right here just to verify that this function is indeed running. May or may not be the lyrics to a song I'm currently listening to. Analyze scanf, so it is not running. Okay, that's a bit interesting. Wait, I think I know why. Okay, this makes sense. So, how this tool works is you you specify the name of the function that you want to actually look at, the actual name of the symbol, and then we'll check it for that. Scanf, it isn't just called scanf, it's this ISOC99 scanf. So I'm going to go ahead and try adding that here. Okay, let's try to rerun it and see if it actually runs the code. Okay, so it is indeed running the code now. So we fixed the first problem. There's now a secondary problem where it isn't recognizing this. Oh, I think I know what the secondary problem is. So this goes to how string detection is a thing. Basically most string detection algorithms that I know of when it looks at a binary, it will effectively, there's a certain byte range where you actually get valid characters. Now, what I'll do is I'll just check, like, is there a sequence of, like, 4 or 5 actual valid, or bytes that are within that valid string byte range, and if so, consider that to be a string. I'll show you what I mean when I pull up Ghidra in a second. Actually, let's just pull up any binary so I could explain why this is a problem. Yeah, go ahead and analyze it. Search for strings. Yeah, so yeah, we specify like a minimum length because we want at least that many bytes to be within a valid character range. And that's also why we can look at things like this. That is obviously not a valid string. However, it just so happens by coincidence that that is like a 5 or 6 byte sequence of bytes that are within the valid like ASCII range, so interprets it as a string. Now, how is that relevant to this? The string for scanf is only like 2 characters long, so what we're going to need to do, at least with this current implementation, is we will need to add additional characters to it. Now, that will fix in the short-term problem, but doesn't get rid of the fact that my string detection algorithm cannot detect strings that are only like 1, 2, 3, 4, even 5 bytes long. So I will need to fix that, but for now, let's just try. So I just added a bunch of characters to it, probably way more than I needed to, but in this case, it should have enough that it actually works with the string detection algorithm. I'm going to go ahead and just run it with a different project. Okay, yeah, that actually got flagged because it actually matched. The string was long enough to be detected by my string detection algorithm. Now, let's go to functions to analyze. We got scanf. Next is fscanf, which file stream. And okay, scanf. Yeah, first thing it takes is a file string pointer. I believe I can try that as standard. I'm going to try it and just write a test case for it real quick. Wait, no, what I'm doing. Okay, let's change this to fscanf and wait, no, I'm doing this wrong. Doesn't it, actually, now that I think about it, doesn't fscanf do output only? Yeah, I'm pretty sure I'm smooth running this. I'm just gonna Google this real quick. Fscanf function. Oh, wait, no, yeah, it does take input. I'm thinking of F, right, sorry. Let's do it from standard in. We will read %s, so that is a bug, into a static stacks buffer. Let's go ahead and make it. And let's see if this is a bug. Okay, that didn't crash, which is weird. 0 times 400. Pipe that into scan. Oh wait, no, I forgot the asterisk there. That's weird. You know what? Just so I'm not like screwing around with basic function declarations, I'm going to leave this for now. So looking at here, we basically have all of the basic functions that I want to implement checks for done. Later on, I probably would want to implement a check for the arguments to malloc and calloc to potentially see. One type of bug I've seen in the past before is where it does a size check, but there is a type confusion between the size being checked and the actual size being passed to malloc and calloc, and later on I'll want to implement a check for that. But I think this tool is almost ready to start being ran against legitimate targets. Excuse me. Though one last thing I would like to change is that bug that we saw earlier with the string detection algorithm not being able to detect if a string is like just %s or smaller than like 4 bytes. I will want to implement a check to see that. So how can we do that? Let's first go to the %s check. I want to first see where is this being called, that way I can understand better how I can, if I'll break anything by changing the function or the functionality of this. Use the stir copy, use format. Okay, cool. So effectively, how this getString@at function works currently is it will use the Ghidra getData@at function, and we provide an address, and it'll try to return the data associated with that. And if it's null, we return an empty string. What I'm going to do is I'm going to change this to an actual, well, put a bit of code here to do a secondary check to just to see if it just so happens to be a string that's only like 2 characters long. Now, how can I do this? I'm gonna look at the Ghidra API docs for a second to check this out. Ghidra get listing. Looking at this function right here, because when you look at what we're doing right now, get data at, that's the return value of get listing, and I forget what it returns. Let's go ahead and look at it. Returns a listing. So here it has the get data at functions, which is what we use to get the string. Now, is there like maybe a get byte function we can maybe use? I wonder if what the get data at function will return. So for this, what I'm going to do is I'm going to add a print statement. So Oh wait, get data at is the function I'm already using. This get data function might be what we're looking for because it returns what appears to be an iterator over a set of data, and perhaps we can get an iterator that starts at the address that we're looking at and then just iterate through the bytes and check that way. Or one thing that we might be able to do instead is Ghidra API set minimum string length. Might be is there like a set string length maybe? Okay, does not appear to be one. There might be some other functionality, but for now I'm going to go down, just see what happens when I try to get a data iterator over that address and that data. So I'm going to copy this. This is get data at string address. For now, I'm just printing it just to verify that we can indeed do it. And I'm going to alter this test case here. That way it is only a string of like 2 bytes, so we can verify if we're doing this right. And all we have to do is just decrease the length of the string to 1. And let's compile it. Cool. Make sure that it is indeed a bug. Excuse me. It is a bug. Cool. I'm going to go ahead and copy it. Okay, let's go ahead and run it. And let's see what happens. Cannot find symbol, get data. Okay, misspelled that variable. Okay, already imported. See ya, Nazem, in the chat. We need to change it from tag import to tag processes since we already imported the binary into the project. Looks like there might be an issue with this line. Okay, it is an issue with this line. I believe it might be that this get listing doesn't actually have the get data method, despite the documentation saying that. Ghidra. Let's look up Ghidra listing. Okay. So yeah, when you get listing and then try get data string address, it breaks, so it doesn't have that method, despite the documentation saying that it does. Get data. Yeah, class not found exception. Yeah, it doesn't have it. So we're gonna have to look for a different method of getting this. Maybe get defined data. This might give us what we're looking for. Does this run? No, it does not. How can I solve this problem? Okay, so I've been streaming for over 40 minutes, and I'm a bit tired, so I'm going to end the stream here. Thank you, gamers, for watching, and see you next time.